Don't say anything now. Okay. All right, so we're going to do a little bit of this today. Piece of paper here. Now, what I would suggest is that you have your notebook out so that you can work with me on this stuff. Although this is not homework, it is work that you're still going to turn in. So understand that you're going to need to, work good notes with me so that you could have something to turn in later in the week. All right. Currently, I've got this set to be due on Wednesday, and just like most things, we'll just play it by ear. We've got 10 problems so far, and then I've got a worksheet that I'll probably give you on Wednesday that's another 10. And I'll probably give you till Friday to work on that. I figure everyone deserves to have sort of a slow startup, I don't want to wear you guys out. I don't want to destroy your vacation by giving you a crap ton of stuff to do right out the gate. Okay. Now we're going to be working a lot with percentages, and so these problems are designed largely to help us think about word problems, but also to kind of use some of our conversion skills between percents, fractions, and decimals. And then we have some more logical thinking problems that are like, how would you actually solve this? What do you need to know? And then what math can we use to make that work? Okay. Now, because again, I only have one computer screen right now, I can't really see very well if you're throwing a hand up in the air. So if you need to ask a question, just feel free to unmute yourself and just say Mr. Easley, and that'll work fine. Okay, guys? Tomorrow I'll have the other computer set up so that the other monitor set up so that I can have my working screen and my gallery screen. So I'll be able to see you guys on one screen and the work I'm doing here on another one. All right, but just today. All right, so here we have. So like with all things, when we're doing a word problem, what do we need to do when we're working word problems? Feel free to unmute yourself and answer. What's one of the things that we should always do when we're working a word problem?
Underline important information.
We can underline important information. We can take notes, right? Yeah. Anyone else have an idea of what some of the things are that are smart to do when we're working on this sort of thing?
Read the problem.
Read the problem. How many times should I read the problem, do you think?
More than once.
Yeah, definitely,
3
right?
times.
I would say 3 times is probably a good number, because the first one kind of gives you a general idea of what's going on. The second one gives you an idea to kind of get rid of the stuff that doesn't need to be considered. And then finally, on the third one, you can actually determine what are all the numbers involved and what are they actually asking you for. Now, sometimes you might only need to read it once or twice, but I think 3 is probably a good bet to kind of plan on reading it 3 times to make sure, okay? As with all things in math, in terms of how you attack a problem, it varies from problem to problem, but that's okay. So a shopkeeper sold some products. That doesn't mean anything. The results of the numbers of products are sold are shown below. All right, well, that's useful. Now, finally, we have a question because it starts with a W, right? Which product had the greatest percentage of its inventory sold? So now I realize that what they're asking me is they've given me 3 items here, and they want to know which one had the largest percentage sold. So basically it means I have to do 3% problems, right? Or at least I have to have 3% that I compare. So if I look at A, it says 40 out of 80. Well, 40 out of 80 is the same as 1/2, which is 0.5, which is 50%, right? Right? Now B is already cooperating. It just says it's 68%. So I don't need to do anything with that. I just need to write that one down. And then finally, C is 0.475. Now, remember that when we're converting from a decimal to a percent, we're going to move the decimal point 2 spaces and 2 spaces only to the right, which gives me 47.5%. Yes? Any questions on that? So obviously that means that B is going to be the answer because it has the largest percentage of the three. Yeah?
Can you please I'm sorry, I got kicked out for some reason.
Yeah.
Can you please re-explain just the main parts?
Sure. So it's the question here is asking us to find out which of these products had the largest percentage of it sold. So we started with 40 out of 80, which is 1/2, 0.5, and 50%. Yeah. Then we had 68% of the apple juice and 0.475 of the cakes are sold. So we showed how we converted a decimal to a percent by moving it over 2 spaces. And by comparing the different percentages, you see that B is the answer.
Oh, okay.
Okay, yeah, no problem.
Easily.
Yeah,
How come you can only move the decimal 2 places to the right? How
Because
come you
it's-
can't do more?
because it's hundreds. So since it's hundreds, 100 is 2 decimal spaces, right? Because each decimal space is a power of 10. So if I move it 1, it's 10. If I move it 2, it's 100.
Okay, I was just wondering.
No, that's a great question. There's nothing wrong with that question. All right. Now this one was a little weird when we did it in second period. So what I want to do is I want to read this, and then I want you to see if you can come up with some ideas on how we could solve this before we actually solve it, okay? Because a lot of these require some good basic thinking, right? You got to just think and go, how would I figure this out? What are the ways I could figure this out? So Dylan works for bananas. Dylan's an idiot, clearly. Dylan receives 70 bananas an hour for his work. Dylan is going to get sick because if he eats 70 bananas for every hour that he works, he's going to be very, very sick. If he reads the newspaper on his break, he gets an extra 20% bonus. Dylan works for 30 hours and reads the newspaper during each break. How many bananas is Dylan owed? Okay. So now I'm going to read it a second time, and I'm going to take it at a slower pace, and I'm going to take some notes because there's a lot of information in this one, and I want to make sure I don't screw it up. So Dylan works for bananas. Yeah. He receives 70 bananas per 1 hour, right? And that's his unit rate of getting paid, right? Remember our unit rates we worked on before? If he reads the newspaper, so it says here, read newspaper, get plus 20%. All right. Now, then it says Dylan actually worked. He worked 30 hours. Now, right now, I'm not figuring anything out. Right now, I'm just writing down the information. And he read the newspaper, so he gets to have the plus 20%. How many bananas is Dylan owed? Okay. Now, if I was thinking in terms of dollars, and I told you that I was getting paid $10 per hour and I worked 30 hours, how would I solve that? Allie?
I'm having a brain fart.
Perfectly acceptable. I have
Would
those
you-
too. Who's got an
Would
idea?
you multiply Aaliyah?
Yeah, Aaliyah, what's up? What do you want to say?
Is it 10
Can you guys still hear me, or am I the problem?
I can hear you, but I can't hear Aaliyah.
Okay. So remember, we could set this up as a proportion, right? So $10 is to 1 hour as X dollars is to 30 hours, right? And we end up multiplying the 10 times 30, don't we? Right? You probably said that earlier, but you cut out, so I didn't hear you, but I figured you knew what the answer was. So this would give me $300. So now that's one way I could calculate that. So how would that work up here then with bananas and 30 hours? What would I do to find out how many bananas that the brilliant Dylan earned? What would I do to figure that out? Oh, gotta check.
Would you do the same thing that you do with the $10 and the 30 hours?
Yeah, exactly. And Jacoby wrote that in the chat too. Good. Yeah. So if I come down here and I look at this, I'm going to be able to say, okay, 30 hours times 70 bananas equals 2,100 bananas. Dude, you're going to be so sick. I mean, not to mention the fact that most of them are going to go bad, right? I mean, he's going to be making like the most banana bread on the planet because he's going to get about 10 of those bananas eaten before the rest of them go bad. And if he lives in Arizona, he might not even get 10 of them. You guys notice how fast your bananas go bad in your house? You can buy them like solid green, and by noon, they're like brown. It's like, what's up with that? Aaron, go away. Aaron, go away, or I'm calling your mom. All right. So this is how many bananas he made for his basic work, right? But what did we say about something else that was happening that was going to increase how much money he was getting paid? Allie?
Well, he gets the 20% bonus because he reads the newspaper.
Yeah, boy, I wish I had a job like that. I'd read the newspaper every day, right? It'd be like, hey, you want to give me a 20% bonus and I'll read the newspaper? Heck, I'm a teacher. When I was an English teacher, I used to have to read kids' essays, and I'm telling you, that was a lot more painful than reading the newspaper. I can tell you that for nothing. Hold on, I got to get Miley signed in here. Hey, Miley, welcome. I got you signed in, sweetheart. So what am I going to do now? How am I going to figure out what 2100 plus 20% is? How am I going to find out what 20% would be? Who's got an idea? Go ahead and unmute yourself and just say Mr. Easley, and you'll get the turn. Guess what?
Mr. Easley, you divide by 20 from 2,100.
You're really close. You're really close. So let's think about this again. What is 20% of 2,100? Now, we worked on some of these before, right? And remember that what does is mean? Do you remember what is means? If I say 2 times 2 is 4, what does that is mean?
Like this.
You had it. You were about to say
what it equals.
Yeah, it's equals, right? And if it says what thing in math do we have that we would call a what? What? I don't know. What number? Maybe X, right? that make sense? And of always translates to multiplication. I better just use the dot. So I'm going to bring down the stuff that I know. X equals 20% times 2100. How can I represent 20% as a number that I can multiply by? What would I need to do to 20% to be able to do math with it? Go ahead and unmute yourselves if you have an answer.
You can turn it into a decimal by moving it to the left 2 places.
Thank you. So it's going to be 0.20. So when I do this, it'll give me what 20% of 2100 is, which ends up being 420. Now, because this is the honors class, I want to show you an interesting idea. What does 1.20 represent as a decimal if we were thinking of percentages? What percentage does 1.20 mean? Jacoby.
120%.
Yeah. Well, isn't this what we're looking for? We're looking for 100% plus 20%, right? So isn't that 120%? Think about that for a minute. If I have 100% and then I add 20% to it, it's 120%, right? So I don't have to do this middle step. I can just go straight here and do a multiplication problem. Now I'm still doing the same math, but it's a little cleaner. Does that make sense? It's a little prettier. So I don't need this 0 because I don't need a trailing 0. So 2 times 0, 0, 2 times 0, 0, 2 times 1, 2, 2 times 2, 4. Oh, look, there's my bonus. Remember, we got 420. There it is right there, isn't it? And then 1 times this is just going to be, and I get 0, 0, 2, 5, 2. I've got 1 decimal place, and so I get 2,520. I got 420 because I multiplied 0.20 times 2100. And so it'd be 21 times 2, which is 42. And I take off 1 decimal point because I have a single decimal place, right? Because that 0 doesn't really count. So 2100 plus 420, there's my answer. Same answer, right? So I got the same answer, but it was a different way to find the answer, a different path. Now, of course, the tricky things about some of these problems is they're going to ask you for what's the amount of the bonus. Sometimes they're going to want to know how much did they get paid for in total. So there's different skills and different techniques that you have to use based on what kind of a problem you're working with. Does that make sense, folks? Every problem has its own thing. All right, let's look at number 3. Now, let's take a look at number 3. Number 3 says that Sophia is a little OCD, and she wants to place a sticker that is 2.5 inches long on a switch box that's 3 3/4 inches wide. And on top of that, she said she wants it centered. So that's how we kind of know she's OCD, right? Because most people just gonna put it on there and kind of be like, it's close enough for me. I'm pretty happy, right? But Sophia has issues, right? So we're gonna help Sophia figure out where she can put, how she needs to measure from the side to put that sticker in the right spot. What are some things you can think about that we can do to try to solve this problem? And then we'll work on the math second, but we should look at what do I need? What is it that I really need to figure out? Anyone? Okay, so I've got a suggestion to find the area or the perimeter. That's a good way of thinking about it. Now, we're not really working with area and perimeter because She wants this thing centered inside this distance. Sorry. She wants this sticker centered inside of this distance. So that's like a side to side thing. Always Jacobi. So what am I looking for? What do I need to know here? What do I need to find out? I need to find out this distance, right? Isn't that basically what we're talking about? How far, how big is that distance? Because she wants to center it, right? Remember, she's got issues. Now, if I center it, these two are going to be the same distance, aren't they? Because if you're going to center it, then they have to be the same length. They have to be, the sticker needs to be the same distance away from the side on each side. Yeah? Hello? Bueller? Hello?
Yes.
Okay. So if I look at this, I need to figure out how can I determine how big X is. So I want to know X equals what? That's what I'm trying to find out. How am I going to solve that? Well, I don't know. I've got two numbers that I know of. What could I do? I've got the whole distance, it's 3 3/4, and the inside distance here is 2.5. What can I do with those two numbers? Tell me, get closer to finding out what these two are.
Subtract.
Yeah, there's a good idea. Who was that? Was that Andrew?
Yeah.
Okay. Can't believe I can recognize all your voices like that. It's kind of spooky. So what am I going to subtract, Andrew? What do you want to subtract?
3 3/4 and 2.5.
So I'm going to do this subtraction here, okay? 3/4 minus 1/2 is 1/4. 3 minus 2 is 1. So basically, how many distances of X do I have?
1 1/4.
Well, that's how the total distance, but I have an X here and an X here, right? So I could say that 2X is going to equal 1 1/4, right? Does that make sense? Because together, these two things are 1 1/4, aren't they? But I only need to know what 1X is, right, Allie?
So could you divide the 1 1/4 by 2 to find just the one side?
Exactly. Exactly. So now if we look at this, we can convert this to something more useful. So we can do it in fractions or we can do it in decimals. It doesn't matter. I can convert this to a fraction that I can divide by 2 pretty easily. My preference is, just since 1/4 is such an easy decimal, it's 0.25. I think I'm just going to divide 1.25 by 2, because I just think that's easier instead of converting this to like an improper fraction and then splitting it up. And then I could do that, but it just seems like more work to me. Now, if you're like a genius at fractions, then your brain is already thinking, well, I'm doing fractions anyway. So it doesn't matter what I say about decimals, you're going to do fractions because that's how your brain works. So now I'm just going to divide. Does 2 go into 1? No. Does 2 go into 12? Yeah, it goes in 6 times for 12. 2 goes into 5 2 times for 4. And finally, 2 goes into 10 5 times. Here's my decimal point. So my answer is 0.625 inches. Does that make sense?
Yeah, I think I got it.
Okay. All right. Any questions on numbers 1, 2, or 3 at this point? Now, none of these are terribly difficult, but they all require, what we're kind of basically doing here is we're learning how to think about these numbers again, right? How do we look at a word problem? How do we digest it? How do we figure out what it is we're doing so that we can actually accurately come up with an answer, right? All right, so we're going to do number 4, and then we're going to be done for today, because I'm not going to do a whole class period because, frankly, I don't want to, and I'm betting you don't want to. So there you go. So let's look at this one. Joshua goes to the market and purchases some products. Which product did he purchase the greatest percentage of its stock? So now it's just like number 1 again, right? 60 out of 100, which is 60%, right? Number 2 was 36%. We don't have to change that, right? And then the last one is 0.589. And if we convert that to a percent, we're going to have to move it to the right twice, and we get 58.9%. So obviously our answer is the first one, right? So some of these are pretty easy. They're just simply conversion problems. And some of them take quite a bit of thinking about it. How would I do this in real life? What would I do to figure this out? And then use the math that I know to find the answer, okay? So there's 5 more problems for this worksheet, but we're doing them tomorrow in class, okay? So we can just kind of do you can see that, here's another one that was like the sticker. Here's another one that was like the bananas. Oh, now this is a bad idea. If somebody paid me chocolates for work, I would look like Jabba the Hutt. I'm fat enough already. If somebody gave me chocolate as my pay, it would be a bad thing. Although I'd probably have a great career in the movies then, maybe. Here's some other ones here. He purchased a toy car, spent this much on ice cream. How much does he have left? And so you can see that these are, again, some, oh, look, Brian, you're going to work in an oil factory, apparently. You're getting $45 a day. Wow, you're stupid. If you're only getting $45 a day for working at an oil factory, you need to get an increase, man, because that's like a high-risk job. So I'm just saying, you might want to think about moving to a different company or, fighting for a better pay, because you're getting about $5 an hour there. That sucks.
But that one's not me because that's not how I spell my name.
Oh, this is a typo.
Well, I mean, there's 2 different ways to spell
I know
it.
this is the typo. It's really spelled Bryan. They just have it spelled wrong. So it's still you. Trust me, it's still you being dumb, working
Okay.
for $5 an hour in some kind of high risk, potentially deadly environment. Okay, come on, man. You should be better than this. Okay. All right, kiddos. So we'll do some more of these tomorrow. And then I'll give you a homework assignment that you can work on for a couple days, okay? My thought would be
You're
that
still
you'll,
recording.
go ahead, what?
You're still recording.
Oh yeah, that's true.